Hello everyone, welcome to this lecture series based on the book The Cauchy-Schwarz Masterclass by Michael Steele, where we will discuss all sorts of inequalities. Inequalities, like the very basic one of Cauchy-Schwarz, are foundational to mathematics and showcasing beauty, structure, and utility. And so this book explores these tools and it blends theory, application, and all sorts of different challenges. And what we will do in this series is we will build foundations, we will explore some applications of the inequalities we discover, we solve problems, and we try to discuss and gain perspective from these solutions. Okay, let's get right into it and start with what this first inequality is, which is the Cauchy-Schwarz inequality. A1 times B1 plus A2 times B2 to AN times BN. This is smaller or equal to the square root of A squared plus until AN squared times the square root of B1 squared plus to BN squared. Okay. If all these a's and the different b's and so given with all of these ai's and bi's being real numbers, and of course the I goes from 1 to n. All of these numbers are real numbers. Okay, how would we prove such an inequality? We can get started with the simple case, which is for only a this first case where n equals 2. B1 squared plus Bn squared. Okay. One possible way to do this is to use a different inequality, which is the or we could take the whole inequality to the power of 2. Then we could get a1 b1 plus a2 b2 square root smaller or equal to a1 squared plus a2 squared times b1 squared plus b2 squared. Okay, let's multiply everything out and see what happens. Smaller or equal a1 squared and b2 squared plus a2 squared and b1 squared plus a2 squared and b2 squared. Okay. Let's see what we can remove. This cancels with this one, this cancels with this one, and then we end up with, and if maybe we can bring this one here to the other side. So let's do that. Then we have 0, or let's just write it out before we do that. So we have 2 times a1 b1 a2 b2 smaller or equal to a1 b1, and both are squared, plus a2 b1 squared. So let's bring the left hand side to the right hand side, and then we get a1 b1 squared minus 2 a1 b1 a2 b2 plus a2 b1, and the right hand side is exactly the following: a1 b1 minus why do I have a b1 here? a1 b2. This one is a1 b2 actually. Yes, here as well. Made a mistake. Okay, so we have a1 b2 minus a2 b1 to the square root to the power of 2. Okay, and obviously this is always bigger than or equal to 0. This is always bigger or equal to 0 because it's taken to the power of 2. Okay, so actually we showed, and of course all of these this inequality is equivalent to the first one that we wanted to show, which is this one here that I marked with the green star. Okay, so we showed the inequality for n equals 2. For n equals 1, it's obviously true. This is a trivial case. Let's do the induction step. Presuming, of course, that you know what an induction step is. So if we have a1 times b1 plus an bn plus an plus 1 times bn plus 1. Well, assuming the induction hypothesis, this is true for the inequality for the n case, we have here smaller or equal to the square root of a1 squared plus until an squared times b1 squared plus until bn squared. So overall, this is going to be let's actually write this differently. We can just write this without actually doing this for the green one. Let's then we shouldn't miss the other one here, an plus 1 times bn plus 1. Okay, and the reason for this inequality is because this here is smaller or equal to this here. And of course, that one just stays the same. Okay, so now we have the right-hand side, and now we can use the Cauchy-Schwarz inequality one more time on this term, just for the case Cauchy-Schwarz. So here we maybe want to write that this is the induction hypothesis. And now here the Cauchy-Schwarz for the case n equals 2. This is smaller or equal to the square root of a1 squared plus plus an squared plus an plus 1 squared, and all of it will be squared, and then plus also another one, a big square root, then the square root of b1 squared plus bn squared plus bn plus 1 squared. Okay, what did we do exactly here? We said we were going to use the Cauchy-Schwarz for the case n equals 2. Our Cauchy-Schwarz for n equals 2 goes to the following. Maybe we use different variables here. Let's say x1 times y1 plus x2 times y2 is smaller or equal to square root of x1 squared plus x2 squared times, oh, that's a very important point. We have to get rid of this plus here. That's not a plus, it's actually a multiplication. Okay, times the square root of y1 plus y2. That was the Cauchy-Schwarz inequality for the case n equals 2. And we basically used this here for the case x1, this here for the case x2, this here for the case y1, and this here for the case y2. Yeah, and when we see that the square root and the power 2 cancel here, we get exactly our Cauchy-Schwarz inequality with the for the induction step, and thus our proof is finalized. And see you next time.